Our last video we looked at systems of equations, but we looked at setting up systems of equations. So we were formulating the equations from like a word problem. Right now, we're going to start solving systems of equations. There are several ways that we can do this, but before we do any of that, we're going to solve it graphically just so that you can see exactly what it is that we're looking at when we say we're solving these systems. Okay, so if you see here, we have two equations. We have negative 4x plus 2y equals 6, and then we have 1/2 x plus y equals 2. Well, these are both linear equations. So let's look at this first one. They're not in the normal, normally we want y equals mx plus b. That's our slope-intercept form. Normally we want that because it makes it super easy to graph. So let's put these into that. Okay, if we look at the first one, we have negative 4x plus 2y equals 6. So the first thing we want is we want the y on one side of the equation and the x on the other. So the obvious thing in this case would just be to add our 4x, which is kind of handy. Now we have a positive x. Not that that really matters. So now we have 2y equals 4x plus 6. So we're almost there, except now we still have a 2 in front of the y. So we're going to divide everything by a 2. And what we end up with is we have y equals 2x plus 3. Well, that's a line, right? Our slope is 2. So slope is 2, intercept is 3. So if we go over here, we can graph this. So our intercept was a 3, so we go up 1, 2, 3 on the y-axis. Our slope is a positive 2, so we're going to go 1 over and 2 up, right? Because it's rise over run. So up 2 over 1 would be here. Or here if we're going in that direction. And let's draw a line through this. Okay. Okay, so that's pretty much a straight line. Okay, so let's look at the other equation then. We have 1/2 x plus y equals 2. Just looking at it, it looks like this is probably going to be pretty easy because we don't have any numbers in front of our y, but let's try this out. So we have 1/2 x plus y equals 2. All we have to do for this one is we just subtract our 1/2 x from both sides. So we're left with y equals negative 1 over 2x plus 2. Okay, so then we go to our intercept is 2. That's here. This one has a slope of 1/2, but it's negative, so that means it's going to go down to the right, right? So it's going to go the opposite direction of this one. And then it's rise over run. Well, our rise is 1, our run is 2, so that means we're going to go up 1 over 2 or down 1 over 2. So we're going to go down 1 to the right 2, or in the opposite direction, we're going to go up 1, left 2. So that's there. Let's draw our line. So now we have this. So when we solve these two then, we're looking for exactly one x and one y, right? So that's the whole point of having a series. Well, on a graph, the only place where they both have the same x and the same y is right where they cross. So that's here. So our solution then is actually where these two lines cross. So that's where our x and y are going to be the same. So we would solve and we would find that point. Okay, it looks like I'm pointing to the red. I'm really pointing to this point right here. It's where they cross. So let's write that out. Solution is where they intercept. Or intersect, I guess. This is why I'm not an English teacher. This is where they cross. Da-da-da. Okay, so that's graphically. So we're just looking where they cross each other. But sometimes you don't want to have to graph to solve. And sometimes that would just be a pain in the neck. So let's say we have our two equations. So we have 2x plus 3y equals 7. And let's say we have x minus 4y equals 5. Okay, so we have our two equations. We have two unknowns. So since we have the same number of equations as unknowns, that tells us that we're going to be able to solve this. But we're going to solve it algebraically instead of graphically. So there are a couple ways to do this. The first way is called substitution. Substitution is sometimes the easiest, but even though it is the easiest, it feels like it takes longer, but you need to know both of these methods, so this is one of them. So what substitution is substitution says, hey, why don't we look at these equations, get one of the variables by itself, and then we can plug the other variable in to the second equation. And everybody's scratching their heads right now going, what in the world did you just say? Okay, we have equation 1 here, we have equation 2. Look at equation 2. Equation 2 looks pretty easy, right? We have x minus 4y equals 5. So if we're looking at that, this x is already, like, it doesn't have anything in front of it. It's just a 1. So the easy way to do this would be to say, okay, well, let's get x by itself in terms of the other one. So in terms of y. So if we did that, so we would add 4y to both sides. So plus 4y plus 4y. And we would say, well, see, x equals 4y plus 5. So that's kind of, if we're thinking of it in terms of like our composites before, this is kind of like our little output. We don't have a number for x yet, we just have x in terms of y. So what that lets us do is we can take that then, and in our other equation, the one that we didn't use, because you always have to plug this into the one you didn't use, what we're going to do is you have 2 times x plus 3y equals 7. But since we got the x by itself, and it doesn't matter which one you get by itself, it just, it depends on which one's easiest. In this case, the x was easier to get by itself, so that's the one we did. But it's totally fine to do this with y as well, or whatever variable you have. So we said that x equals 4y plus 5, so what we can do is we could put 4y plus 5 in here. So now all of a sudden, check this out, we have numbers and we have variables, but we only have one variable, we just have y. So since we have one variable and one equation, we can actually solve for y. So that's what we're going to do. So we multiply, so we're distributing. So this gives us 8y, and then 2 times 5 is 10, so 8y plus 10 plus 3y equals 7. So then we say, okay, well, 8 and 3 are like terms, so we could combine our like terms. So 8 plus 3 is 11. This is 11y plus 10 equals 7. And some of these you're going to get fractions, and that's totally okay. We're not actually doing a lot with our fractions. We're just going to have it. Okay, so we're going to subtract our 10. And so we get 11y equals negative 3, because 7 minus 10 is negative 3. Now we're going to divide our divide our 11. And we say, okay, y equals negative 3 over 11. So we've already solved for y then, right? This is y equal to a number. So then what we do is we take this y equal to a number and we plug it back in, and we're going to solve. Now if I had been nicer, I would have used better numbers, but that's okay. That doesn't totally matter because you might not get nice numbers on the test. So we're just going to plug it in. It's just a normal number. So since we solved using equation number 1, this was equation number 1. When we get an answer, we're going to plug it back into the other equation that you didn't use. So we're going to use equation 2 this time. So this is x minus 4 times y equals 5. And you're probably looking at this going, this is about to get ugly. So, okay, so we have x equals 4y plus 5. I just moved it onto the other side. And now I'm going to plug in. So we have 4 times negative 3 over 11 plus 5. So this is negative 12 over 11 plus 5. Then what you're going to do is you're going to turn this in, you want the 5 to be a fraction too, because you want them to be fractions with the same denominator so that you can actually add these things. So we're going to say, okay, well, we want it to be over 11, so we're going to multiply 11 over 11. That gives us negative 12 over 11 plus 55 over 11. So this is 55 minus 12, that would be 43. So that's 43 over 11, and that's our answer. So we have then, if we write the answer out here, we have x equals 43 over 11, y equals Negative 3 over 11. And since you're not sitting there with calculators, or you might be, but let's pretend you're not. If you don't have a calculator, I'm not going to make you divide these. This could get super ugly if you're trying to do this in your head. So that's just your answer. We'll leave it just like that. You don't have to do anything to it. It's okay if the 43 is bigger than the 11. It's kind of a, what is that, an improper fraction? But we don't care. That's okay. As far as pure math goes, this is the answer. And we don't care what it looks like. So, okay. So that was with substitution. Now I realize at this point the video is getting kind of long. I recommend pausing for a moment so that you can regroup. I would sing you hold music, except your ears would probably implode. Okay. How about, so we have our second method of solving this is elimination. But this video is getting kind of long. Let's just go ahead and pause it in general. So this is the end of this video. I'm going to post a second video on elimination. Okay.